For question one, we need to get the big fz and small fz with z equals to x plus 1, x plus y. The first small question is using the convolution approach. We can firstly write this convolution that small fz equals to small fx multiple small fy, and we just firstly find the approach that x equals to u alpha minus u alpha minus 1 and y equals to u alpha u y minus 1 minus u 1 y minus 2. So first we can get this answer, and the original answer is just the result. We can shift to one position. It's okay. So we can depart this integral and then use this formula that this components decide the upper bound and this decide the lower bound, and this is any function, can be any function, and it equals to this one. This one is to guarantee that when it is to guarantee that the result is zero when to some specific situation. So we can just write the answer like this. This is a upper bound, and this one, and it can be departed into 4 different parts. This is the second part. This is the third part. This is the final part. And after we write this, we can also use this formula and this formula to get the derivative of this one, of these things. Which can be write as there's one d alpha u z, and this part is such as this one, and this part is as this one, and this part is as this one. So finally, we can it is simple to calculate, and we can get this answer. This figure, we draw this figure, is pretty like this, and we move it, shift it right one position. The final answer is this one. And the second method is need us to use the geometric method. We can just cut it into 2 different circumstances. The first is that when z was small or equal to 1. Also, we first find this. We let x equals to this one and y equals to this one, and then shift it right. So it's pretty like this. It's pretty like this. It is z, and this part is the square of this part is fz, big fz equals to this square divided by 2, and that's the derivative of z. We can get small fz equals to z, and when z is bigger than 1 but small or equal to 2, we can get this figure such as this. And it's obvious that this part is the part that we need to find. We can find it. The space of this one is the this square divided by 2 minus 2 small triangle space, which equals to this one, and the final answer is this one. Small fz equals to minus z plus 2, and we can just uh, we can just add them, and when z is bigger than 2, the probability is 0. So so we can just add them and finally find this answer the same as the first method, this one, and after that we can shift it right one position and we can call the final answer like this.